Hey there YouTube, this is Tyler, N7TFP, and today we're going to talk about the oscilloscope. Oscilloscopes have been used in electronics for quite a long time. They're a very useful piece of equipment, and many amateur radio operators use them in their shacks for all kinds of various purposes. The versatility of the oscilloscope is probably one of its most important features. The oscilloscope essentially is a graphing device. It allows us to graph time on the horizontal axis and voltage on the vertical axis. One of the biggest advantages of the oscilloscope is that the time base, or the amount of time it takes the beam to sweep across the screen, is adjustable. We can adjust it so that it's very, very slow, operating at a speed like this, or we can make it very, very fast to the point where it looks like a solid line. All these different ranges of speed allow us to observe characteristics of time-based circuits or time-varying circuits at all sorts of different frequencies. We can observe the output of our transmitter or see the output of our stereo system. Those two things operate at very different frequencies, and we can actually look at the voltage-time relationship of these outputs. The oscilloscope that I have here is a Tektronix 2213A. It's an older oscilloscope, but still a very nice piece of equipment. Modern oscilloscopes these days are becoming more and more digital based, meaning that they're not actually using a CRT display like this one here, but they have a computer screen here, and all the circuitry is done digitally, which has some advantages, allowing you to save a picture of the waveform that you're looking at and other things like that. Let me give you a quick rundown on what the basic components of an oscilloscope controls are. Here we've got the screen. This is a CRT display. We have a couple of controls here that adjust the beam, like the brightness and the focus and things like that. And then we have two channels. This is a two-channel oscilloscope. Some have one, some have two, and some have more. And we can switch between these two channels. Right now I'm only using one channel because I'm about to show you a couple different waveforms and what they look like. And we can put those channels up on the screen together. For example, I can shift one of them up, and then I can switch to the other channel, put it down here, and I can graph two lines at the same time. So I can look at like the input and the output of something like that if I wanted to. And I can control the sensitivity of each of those channels as well. This is the next portion of the controls. This is the time control. This controls the sweep time, or how fast the beam is moving from left to right. If I select all the way over here, we can see that this is 1/2 second per division. And all these little black lines on this grid here are a division. So right now it takes 1/2 second for the little green dot to go between two of those black lines. And we can speed it up. We can make it like that is 1 millisecond between each division, which at that point just looks like a solid line. So there's really no observed change as I increase the speed, but I can increase it all the way up to that's 1 microsecond between each one of those little lines. And if I go even farther, I can go to 0.05 microseconds. So it's a very, very quickly very fast scanning speed. It has some other features as well on the front here, but they're not really that important. That's the main kind of gist of it, so you kind of understand how that works. Let's look now at a couple different waveforms and what waves actually look like on an oscilloscope. Okay, so what we're looking at right now is just a basic sine wave. This is probably one of the most common kinds of waves you'll come across when you're dealing with AC circuits. The power in your house outlet looks, hopefully, like a sine wave. There's all kinds of things that produce sine waves. Radio transmitters produce sine waves. All sorts of things. We come across them in trigonometry a lot, and they're probably one of the most common AC waveforms. But there's a couple of other kinds of waveforms that you might come across when you're doing experimentation. For example, let's take a look at a triangle wave. This is a pretty much almost a triangle wave. It's not a perfect one because it has a little bit of a roundness here on this line. It's not perfectly straight. Let me use the triangle wave as a way of showing you a little bit about how the oscilloscope can show different parts of the wave. For example, if I slow the beam down, that is, I reduce the scanning speed, it's almost like zooming out on the waveform. And if I slow it down enough, you can begin to see the line traveling across the screen there. And you'll notice that when it moves quite slowly, the waveform basically just looks like a vertical bar. But if I speed it up and I go faster, then at a certain point you're able to see the waveform appear on the screen. Now on the vertical axis I can increase the sensitivity or decrease the sensitivity as I please. This is what a musical chord might look like. This is a major triad chord. And if we look at, for example, all the even and equal harmonics, we get something like this. And we can try all the odd and equal harmonics, get something like that. This is the number 2 on your telephone. When you press the number 2 and you hear the dial tone, this is what is actually being produced. To demonstrate the change in frequency of a wave, let's look at a sine wave that starts at 0 and goes to 1,500 Hertz. You can see the frequency increase, the wavelength becomes less. The oscilloscope certainly has lots of practical applications in any amateur radio station, and amateurs have been using them, like I said, for many, many years. Some of the other things that you can use an oscilloscope besides just looking at the output of a computer sound card, you can look at the input and the output of your power amplifier and make sure that it's not distorting your signal. You can use it to ensure that the output of your AM transmitter isn't being overmodulated. You can use it for many, many, many different kinds of things. You can use it when building your own radio to ensure that your oscillator is performing as it should. And you can use it for, again, like I said, the list goes on and on. It's very versatile. It's a great piece of equipment, and if you don't have one, you don't necessarily need to buy one unless you're doing lots of serious kind of experimenting on your own. But if that's what you're into, an oscilloscope is probably a very useful piece of equipment. If you have any more questions about how you use the oscilloscope or anything like that, you can either send me an email or leave a comment below, and we'll try and get your questions answered as quick as we can. Thanks for watching, and we'll see you next time. This is Tyler, N7TFP 73s.